Hey guys, this is a video about update suppression and block updates. I'm going to show you guys what this device behind me is. It's a device invented way back by Panda and Spire and those guys back in the Zip Crowd days. And it's been around for quite a while, but no one has actually made a proper video about block updates and how to suppress them and what it means and how it can be used. And I will go through all the details and I'll show a little bit of code and a little bit of examples. And then lastly, I'll show you how this device is used. So I'm going to go through all the different ways that you can actually send a block update, and the game actually recognizes the block updates in a different way. And some of them aren't block updates, some of them are. Most people actually are familiar with this, like if you remove a block or place a block, or I don't know, redstone updates. If you, for example, change the repeater's delay, or observers, this is a trapdoor. Trapdoors, for example, send an update because there is like a redstone dust that it sends updates through. You can see that the redstone over here changes when I open the chest, or the trapped chest, not the chest itself. Stuff that like redstone rails obviously change up block updates, things that the player can interact with, dispensers firing and all of that stuff. TNT and like for example daylight sensors have like a different way of sending block updates. They can sort of send a block updates when they explode or when the daylight sensor changes state. Similar for crops and stuff. These are influenced by random ticks. So the random ticks that you can actually change by game rule, random tick speed here. These can have influence that you can set it to 3 or you can set it to 0, and all the like 3 is basically the standard of vanilla non-modified survival. And there is difference between all of these. There's a unique things that happen when the player actually interacts with blocks or places blocks, compared to, for example, let's say a dispenser firing, or let's say an observer doing its thing where it sends out an update. Or when you change the repeater's delay like this is a player action, but when the repeater itself changes output or the state 2, 4, 6, or 8 game ticks, when the updates happen in the front of it. Let me just illustrate that by just placing it on a trapdoor here. When you change the state in front of the repeater, the thing that happens in front of it is different from the stuff that is happening behind it. I am placing this torch. This is a player action. The repeater opens this trapdoor as a redstone action. It's different than a player. Redstone rails and other things that are wire-based, they send the updates from the source to the point where they need to go. For example, if I had a long delay of redstone here, and I placed, for example, a torch like I did over there, this action of me turning this redstone dust on, all of this is player updates that are propagated out of this source where it's a player action. So it's critical to know the difference. If you don't know the difference, is that if the actions that come through a repeater, for example, these are no longer a player action because they go through the output of the repeater. So it's a huge difference. So it's really important to know all this stuff because we're going to talk about it when we get to the update suppression. And it's why it's really important is because player actions differ from the actions that happen that are based on block events or tile ticks and stuff like that. Redstone, for example, are updates that come from tile ticks. Pistons and such that are here, they're block events. Observers, for example, are also tile ticks. And you have to know the difference. You can easily detect them in different ways. I mean, here's a floating sand. If I remove this redstone dust, the observer doesn't update, but the block update detector does. So there is different variety of updates as well in the game. I'll show it in the code what the difference is. And most other events like entity updates like TNT, or for example a pressure plate here activated by this cow, they're events based on entities. For example, this villager can, for example, pick up the crops. That's entity updates. Regular entities just by themselves, like this boat sitting on the on regular glass, or this cow standing on blocks, or like armor stands and stuff, they don't send any updates on their own, but they can, for example, interact with other things that can send updates. Like, for example, the crops here can change state, and the villager, if it picks it up, if the villager picks it up, not like, for example, if it's trampled, or if no, actually that's also a part of the entity update. If the villager tramples it or such, but if there is like water source here next to him that flows in there, then obviously it's not going to be an entity update. It's basically the water itself that updates it, and water is also part of tileticks. So all these different updates are differing, and they happen in different phases of the game, and you have to keep that in mind when you're actually doing update suppression. It's really important to know the differences. So the main part about this update suppression is to know the difference between what is a player update, that for example is me interacting with this lever, opening this, for example, trapdoor, fence gate, or this door, or for example if a villager accidentally triggers these, or a redstone updates these block updates and stuff. And I need to show also in the code which update path the game takes. When an update happens, it propagates. For example, like for the redstone dust we just saw here, or if you want to, for example, chain react, placing a bunch of signs. If you have banners, for example, usually people place a bunch of banners on top of banners, and they sort of chain a bunch of updates next to each other. Obviously, if you break this banner, it's successively going to break in this shape in that direction. But if I make a fork here, then this junction where the updates can follow in this direction and this direction is different, then how do you know which direction they take? That's critical to know when it comes to update suppression. And this is something that Panda and those guys worked on. I'm pretty sure that most other people have actually talked about this, so I just briefly went over it so everyone is on the same page. This is the update path. If I open the F3 screen, illustrate this because of the update path that happens very critically in this rail update order, and without understanding the update order, the update suppression becomes completely confusing and just looks like black magic. And so here's the MCP, and I'm currently looking at carpet code. I'm going to delete this part of the code which is carpet related, so we can actually look at the vanilla code. This is MCP code, so MCP mappings. Obviously Yarn have different mappings. So this neighbor updates happen. This is usually where the game triggers the updates. They come into this this part of the code where the game first attempts to go west, east, down, up, north, south, as just we saw in the game. And also the update path for observers is completely different. This is a little bit different for observers, where observers kind of do slightly different updates event system. It's not the same as the other updates. So that's why observers can sort of sometimes behave subtly different from the redstone updates. Now quickly, before I go back into Minecraft, I'm just going to show get block states and set block state. Here is set block state. And regularly when the blocks are being updated, you can see that the bottom here, observer updates are here. And a special flag can be set to avoid updates from observers. That's why you can actually noticeably change updates that can happen. Just as we saw, observers didn't get triggered when I removed that redstone block. And when you want to actually update blocks themselves, you have to actually go into this modified code by carpet. It looks identical in vanilla, and here is where the block updates happen. If we go down here somewhere, then you can actually see that the updates can be avoided by just removing this flag. And in vanilla this doesn't exist. That's why it's a little bit difficult to change the flag and avoid updates. Avoiding updates is kind of important, because if we go back into the game, you can see that this entire device over here is based on avoiding updates and creating these unique contraptions and portals that aren't fully updated, or floaty sand and stuff like that you can for example build a simple sand that can float by avoiding the updates that are reached to that reaches this sand block. And this is a really simple way to avoid updates, by just placing this this grass over here. But if you want to, for example, make a floaty rail, that's a little bit different than this thing over here, because you can't exactly place a floaty rail on top of this double grass block. You can place sand there, but you can't place rails on top of double high or too high grass. So to create these unique block updates that are suppressed, you need to basically abuse this stack overflow. And I'm going to show it quickly in the code. Now here's the tricky part about update suppression. There is an actual intended way to update suppress. This is not actually something that is just invented by Panda and those guys. This wasn't supposed to happen. Like when an update suppression happens, the game actually catches this event, and it's a Java event that basically is on the underlying subroutine that Minecraft is running. And it throws this exception. It's basically when the stack overflows. And I'll talk about it in a short bit here. And when the stack overflows, it's caught and it's been processed. It goes all the way down here into the lowest levels of Minecraft where the game loop happens. And when the game loop detects this exception, or when the game basically does something it's not supposed to, the game sort of gracefully shuts down the server and just sends a bug report to Mojang, or to you that you can send to Mojang. But the problem was that the Panda guys found a workaround around this problem, and that is because of the updates being caused by a player, for example. When a player updates a block, like for example me clicking this lever over here or opening this trapdoor or this door, then these block updates that are happening by the player, or these are different than those updates that are happening for otherworldly event, for example redstone or pistons or TNT, whatever it is. So if there is a player update, it differs from the crash perspective, so that the crashes that are caused by players are gracefully caught and not handled. And this is the trick about update suppression, because what you can do is to cause this crash that it isn't like processed. It doesn't trigger the server shutdown, and because of that, you can just make these unique events that just make, for example, Rails float portals not being properly cut in half and whatnot. So how do you even trigger this update suppression? Simply just filling the stack, and the stack is something I need to just draw up an illustration to describe, because it's kind of an abstract term. So here it is. This is super simplified. Obviously it doesn't look like this, but this is Java, a Java program. Minecraft is running on this Java program, and inside of this Java program, or the Minecraft program, there is a stack. Just imagine as a magical little house, or whatever you want to call it, and in each floor there is different kind of levels of empty rooms, and you can fill these rooms with a bunch of updates, and each update are caused by these, for example, these updates that we looked at before, and each update is one of these updates that are caused by this, for example, the calling this method. For example, this first line is when you're actually calling something updating towards the west. For example, if there is a bunch of rails leading in that direction. So this is, for example, something that is updating towards west. Me flicking this lever updates this rail, that updates this rail, and so on in this direction towards west, that you can see here. And that's basically the same thing what's happening in the code. It updates the west block, then this next update recursively calls the next west block, and so on until it reaches the end of this line where the last block updates nothing, and then it just stops. So that's how you can actually define it. But every time you go from this block to this block, you basically fill this stack over here. There's a rail that is being updated here. Okay, here it is. Let me just import this fine rail. Then we have, for example, updated this rail. And this rail is going to update a different rail. So now we have gone 2 stacks deep, and then 3 stacks deep, and so on and so on. But what if we actually sort of fill up the whole house with rail updates? We don't have another room to fill. Then what happens is that the game basically throws an exception. It just goes like, the house is full. This game can't handle more rail updates. Let's shut this game down. That's what basically happens. And that's basically what this code over here with the Minecraft saying, shut the server down, we don't have any more room, and we have basically, we don't have it, we need to stop updating. And given that Minecraft doesn't know what to do when you're sending way too many updates, it just stops working. And what the guys by Panda and Spyro discovered was that the player updates can't handle these updates. What they do, instead of shutting the server down, they just simply don't do anything. The game just continues as per normal, but the updates just completely stop, and whatever that was supposed to happen just stops happening. So how do you abuse this? This is kind of a simple thing. What it basically happens is, like, for example, if I place a block here, whatever updates that were supposed to happen after I just placed that block stops happening. So let's just let me just demonstrate that. This is a demonstration of what happens when those updates reach that limit. And this is me as a player removing this block so that the updates are being suppressed by the player. And you've probably seen this before, the Rails updates and these banners just stop updating. Clearly, if you actually remove a block, a regular block, and there's a bunch of banners attached to it, they're supposed to sort of pop off, but because we're suppressing them, the banners don't pop off. And this is what happens if the game or in-game events, non-player events, kind of update the rail. As we just demonstrated before, it was like there was a repeater that kind of sort of update the blocks in front of it. Don't do this. This will crash your game. So, yep, there we have it, a game crash. And that's not really good. So you can actually look at the reports, but it's kind of redundant. We already know what the report will say. It will basically say that something about along the lines of, let's just look at it, why not? Oh, fantastic, this news loader doesn't work. Okay, that was a technical difficulty that just happened. Let me just show you. This is this auto suppressor world. When I just got a crash in single player, these two files were deleted, the levels.dat and level.dat.old. Both of them were gone. I had to just basically take a, I don't know, go into this random other world and just take the level.dat and move it back into the this world, because apparently if you don't have those, then you can't actually log in. And now you see the name is incorrect. You can obviously rename it to whatever name you want to, but the gist is that that file was gone. So in survival, be careful when you're testing this device. Apparently it just causes issues. Now I'm actually in a different location. I have to actually go back to that device as well. So issues like that can actually seem to occur. So be cautious about it if you do these tests in survival. So this is the carpet server, and here is the date of this carpet server. Any versions above this carpet server version has this game rule called update suppression crash fix. If you enable this crash fix, then you will no longer get those annoying crashes that update suppression gives you. Then the whole game, including observers and everything else, behaves as if the player were to create these events. And then you will actually be able to do update suppression that isn't player driven. Basically, other blocks can also update suppress and whatnot. But at least that's the carpet rule. This is it. You can also make it permanent on your carpet server, so that if you're actually playing around with this update suppressor, you don't cause a crash on your server. This is some problems that can happen if your world crashes. Then some of these pistons might go out of sync. For example, this piston was left like this. So be careful, just take a look. If the device doesn't work, it's because some of these pistons have caused issues. And make even sure that if you're trying to fix this device, just don't fix it when it's on, because you will have automated crashes. And when the server comes back up again, if you log back in, it's going to re-crash. Turn this lever into the down position. That means that the device is off. And then you can go and do your repairs and then go and turn the device on. So the first thing you need to basically do, if there's pistons in this shape, there was a couple other pistons that was in this shape, make sure they're in the up position. And then when you do that, when you actually fix this rail, put a couple of blocks here to make sure these rails are not powered. They can't be powered, because if they're powered, just place a block here, and then these rails will go into the state where half of them are on and off. You can even place a couple of blocks here, remove these, and then you can go and repair your device. And then lastly, come back here and turn the system back on again. If you don't do that, you will cause issues. You will cause continuous crashes. And just a heads up, I was actually doing some experiments and I accidentally sent an incorrect update. So I put an observer here and stuff like that. If you want to re-update the machine, for example, if it's turned off right now, if you update it, you can see some of the rails haven't updated. Don't play around with it, don't place observers here and stuff like that. What you can do is just to flick this lever, turn it on, and then the lever should be up in the up position where it wants when you want to auto suppress it. Given that this is an automated suppression device, it means that it updates these rails, and it means that if you're accidentally going into a crash because of the way that you can actually accidentally cause a crash by updating it using, I don't know, water or observers or something else. Maybe these pistons starts blinking. So in random ways you can cause a crash using a redstone device around this machine that can update it instead of having a player update it. And then it will completely shut down the server. And then when you try to load the server back up, you're loading it by just logging in next to this machine, and then you will immediately recrash the server, and then you can't even load this area anymore. So one way to safeguard against that is to make sure that you can turn off this device remotely. Let's say your friend can log in from outside of render distance. I didn't make the line long enough, but just this is outside of render distance. He will stand here next to this lever, and then he will flick it. And then the second this power line turns on, the system will turn off, and then the person that can sort of repair this machine, he logs on. He might crash the server one last time, and then after that, the machine is sort of repairable. You can kind of come in here, then it's pretty much like turned off, and then you can repair whatever you need to repair. And then you're outside of this crash loop that you can get into. So be really careful when you make this device automatic, like when you turn this lever off. And this is what you can do with this floaty rail stuff. It looks pretty cool. I actually like the idea of it. You can just make these floaty rails. The updates basically go from the block into the banner into the rail, as we just saw with the update path. And you can just avoid updating the rail because they go into the update machine and stop. If the machine wouldn't update suppress, the update suppression would not kick in, and you would basically have all the updates go from the machine all the way go into the machine, update all those rails, and the game would come back here and go like, oh, there's a rail up top here, let's just update that too. But it doesn't happen because the game doesn't reach this part of the code. It just crashes inside of that rail system over there. And if you do this fast enough, then the update suppressor won't be able to suppress in time. But you can make some cool stuff here, like you can place a minecart on top of this, and then you can, I don't know, ride around here. Looks pretty cool. You can use an activator rail, but not a detector rail. The detector rail sends an update, and obviously updates are bad here. If you get an update here, these floaty rail will get activated, and they just not work. But an activator rail is useful. For example, I mean, you can, if I stop flying, if I go through this one, it sends me off on top of this rail redstone block. And if I'm not sure if you can actually remove this redstone block, maybe there is a way to remove it. But as saw before, if this minecart goes over the detector rail, then yeah, all the rails break. That's not good. There is other stuff that you can also do. As you guys have been seeing, I've placed banners. When a banner is placed, the last thing the game does after placing the banner is to set the color of the banner or the shape of the banner. Because the game crashes before it reaches that point, the banner goes into the default state, where the default state is the black banner with metadata 0. You can see that there is a 0 at the very end of this, inside of the parentheses. There is a 0 there. That's why the banners, all black banners turn black. Yeah, there is also other stuff like skulls. Any type of skull, wither skull, turns into the default skull, which is the default skull is 0, which is a skeleton skull. And I've actually made a video on this stuff before. If you just place it, this is actually not a skeleton skull. It's a wither skull, but it turns into a skeleton skull. The flint and steel doesn't crash, but the fire block can cause crashes if the machine is fast enough. If I place a fire there on top of this block, it will crash the machine. Don't do that. But if you flint and steel directly into the rail here with nothing underneath it, then you can also see that there's durability loss on the flint and steel. But if you re-update the flint and steel, it's not there anymore. The flint and steel doesn't lose durability, or any other tool, because apparently the deduction of the durability happens after the update path, so you don't lose that either. And a couple other nasty details, you can duplicate blocks. If I place the block there and click, and I'm in survival mode, you can actually update, you can place blocks that never gets placed into the world, so the reduction of the item count in your inventory happens after the update path, so the update suppression basically stops you from placing blocks. You can, for example, duplicate blocks, regular blocks, just diamond blocks and whatnot, but you can't duplicate inventories. If you place, for example, a shulker box, so we're back in survival, shulker box full, place it. Now I'm going to mine it slowly because I don't have a pickaxe. The shulker box drops. There is a shulker box with nothing inside of it. Now the other shulker box that I didn't place is back in my inventory, but we just got a free shulker box. It's empty though, it doesn't have metadata, but you can do shulker boxes like that. Just the shulker box itself, not the content. This makes it a little bit difficult to use as a duplication device, but obviously you can use it as a duplication device in some ways, and you can use it as anti-durability, but it's kind of useless. The best use case, in my opinion, is this one, where you can slice portals and make really efficient portal farms. And even better than that, you can also make some floaty rails that are cool for decoration. You can make some stuff that are based on update suppression. So the whole gist is that you suppress states of blocks that are not supposed to exist. You can't, for example, update suppress plants, because plants gets ticked randomly, and when those ticking blocks, for example, get an update, then the game realizes, oh, these things aren't supposed to be there, and it just pops off. You can, however, make permanent update suppressed portals that never go away. But there's a problem if someone accidentally just places a block there, and then you have a broken update suppressed portal. So be a little bit careful around these portals that are update suppressed. Okay, here's just a simple demonstration of the update suppressor. And besides making floaty banners, for example, you could do something similar to this, where you place a banner and then you remove the block. You can place two banners that face each other. That's a simple trick. I mean, here's the invention that Kaylee showed on her channel. I'll link the video in the description. You can place a block here, and then you just remove this block. You place the banner against the other block, and then you can just remove this block over here. You have a floaty banner which wants to pop off, and then what you do is to slice the portal. And as we see with this update path, when you remove this block, it will clearly want to go towards the next block, towards the west block. That's what that big arrow is telling us. So from this block, it wants to go into this next block over here. And then when it reaches this block, this new block wants to also update blocks around itself. So what this block does, it wants to update this block first, amongst the blocks that are above, below, in all directions. When it reaches this block updates the next block to the west again and again and again, until we reach this rail. This is the most west block. Now this rail wants to update the air that is on the west side, but there is nothing there. Like, there is nothing on top of this quartz block. There is air there, so air doesn't update. So what it does is it tries to go back, because the orange arrow first goes this way and then back. When it goes back, obviously it just came from there. There was a banner there. It just popped. There's air now there. So what can it do? It can't go back. So what it tries to do is go down and then up. There is still nothing there because there is just like a block there. The block does nothing. and then it tries to go this way, and then you can see that the red arrow is pointing the last direction it can go, and then it just keeps traveling towards these rails and then goes into the update suppressor. And amongst all these rails, the stack just completely flows over, and you get this exception that is supposed to be caught and crash the server, but obviously this little detail where the player updates don't get caught. So now if we just remove this block, you can see that that clearly the portal gets sliced. That's how it actually is done. And this was a really cool invention by Kayla, actually, because you can now use these portals for example, mob farm. KK just made a video based on something that Robitobi and Nessie worked on, a mob farm, pigman farm that is really cool that they actually built in survival, in Untitled Survival. So I'll link those videos in the description. So now if you want to control updates, avoid updates that are caused by repeaters or water flowing, whatnot. So be paranoid around your update suppressor. Don't build it on grass, for example. Grass sends updates. Don't build it next to crops or trees, or I don't know, build it wherever there is no updates. And this needs to be sterilized. So if you have a survival world, sterilize your entire environment. This glass world is very sterile, not much happening here. And after, obviously, when you have built your update suppressor, you can build it in any way, as long as you copy this design. There is a bunch of rails here. Simplistic. This part is actually not mine. This is pretty much Panda's. The only thing I did was to basically put down. Oh, this guy is not supposed to be here. Get out of here. It's going to probably cause issues. The stuff that I added down below here, just to instantly update it, and managed to put an observer on this side to catch the updates and re-update, suppress the rail system here. And this part, this bloodline here, this was something that Robitobi, I'll link him as well in the description. He found a way to actually get these rail updates to become kind of reliable, because apparently there was inconsistencies in the rail updates. So copy this design if you want to extend this line that way. You can also extend and redirect the rails in a different direction, like for example this direction. You just need to grab the updates from this piston and build something much similar to this setup, where at the very end of it there is a block or a powered repeater, and then you can pretty much extend it left, right, and all the different kind of directions, as long as you follow the main update suppression path. So I'll just build it up and just show it as a demonstration. Here's a simple example of the extension that you can actually create, and a couple of problems that shows up. For example, now that the suppression has been automated, I can just set it up, and you can see that the rails here updates. And if I, for example, place a block here, the updates propagate into this rail and go into the machine, and that means that I can actually create like an extension of the block update path. And a good demonstration of this update path is just shown here. The game first goes towards west, which we are going. If I place a block here, let me just place an obsidian block so it doesn't get caught up by that slime block over there. So the updates go first that way. You can barely see it. It doesn't go this way. If I place the obsidian here, same thing happens. But the reason that this shape of these redstone block and the pistons look the way that this thing looks is because if I place the, for example, obsidian here, it doesn't re-update. And so in some instances, this can cause an automated crash loop. This is obviously an automated system, so it re-updates itself, and this re-update system can sort of cause a permanent crash loop on the server. So be a little bit careful about this device. It can cause issues. So now to mitigate that problem over there, I have to go here and update this rail over here. Obviously it doesn't work. I need to fully remove all the updates. There we go, now it works. So here's a demonstration of what I meant by the update suppression. So the red boxes here, they're representing the rails that we just saw. So this large bulk area here, this is where the rails kind of cause issues for the game. They fill up the stack, and the game will basically update suppress because the stack overflows. So what you want to do is to basically reach this goal where you somehow manage to enter this red zone, and then you cause the update suppression to lead into the machine, and then when it tries to update all of these blocks, all these rail blocks, they're not supposed to be on. They're budded, and their budded rails keep updating, and the game just crashes. If the player would update these blocks, then the game would just basically stop, and then whatever code that follows will stop. So how do you lead the blocks updates into the rail? That is simply by directionality of the update path. And you just saw that the update path can be like controlled using the direction they go. They go first towards west and so on. So and a simplified 2D illustration here. Let's assume that the orange is pointing this way. You have, let's say, a banner here on this black box, and behind it you have a grass block here. So then on top of this grass block we have, if something that you want to update suppress. And let's just illustrate that with, let's draw a rail here on top that we saw before. And on top of this, the player then mines this block over here. Then the updates will basically go towards the rails and then into this device. So you're controlling the path of the updates. Here is the last block you should update in this particular setup. Updating these rails here isn't a good idea. I'm not going to attach it. But you can see that I just made a snake version here where the block updates go in different directions. And if I remove this block, then clearly, according to the arrows, the update should go west, which it does. It picks this banner, and this banner then keeps updating through this snake, hits this rail. And if I do that, you can see that these banners that were floating on top, they didn't get updated, and these ones didn't either, and so on. So you can control the update path using banners and using different tricks and a lot of stuff. So you don't need to actually build your update suppressor here. You can control it somewhat with banners. So you can lead the updates in different paths in different directions. So if you want to build one of these rail systems, you can use banners or other tricks. Or for example, if you have like a device far away from your update suppressor that you want to suppress, you can use banners for that. You can also just simply straight up use banners to cause the update suppression itself. But if you want to have a reusable update suppressor, this is probably the most compact that I know of. And you could probably make some some trickery here to actually bud more and make it wider maybe. But in this case, I just got lazy and I just did this. There is a single repeater that's updating 31 wide rails at once. One last thing I need to show you guys about update suppression is this little code here at the very end. In the JVM arguments at the very end, you can see that there is a bunch of stuff there. At the very end, I added XSS and the size of the stack. So you can control the stack size. In Java, you're allowed to change the stack's size. On Windows, the regular stack size of a 64-bit version is XSS 1 megabytes. That's the standard Java size for Windows. If you're running it on Linux, then the XSS is usually 10 megabytes. And if you have a 32-bit system, it's actually a little bit smaller. It's just 320K. This is just Win 32 bits. This is Linux. And just Windows is, I don't know, any Windows, I think most Windows have like the stack size of 1 megabyte. And I'm not sure about Mac. I've not actually looked that up, but I think it's also similar to Windows where it's just 1 megabyte. You can change the size. For this video, I had to reduce the stack size slightly because if you don't have the correct stack size, then this device doesn't actually update suppress. What happens is that all these rails, all the way to the end of it here, except for this last row, become fully turned off, and the system isn't update suppressing. We can just change. Let me just change those arguments, and then we can see what happens if the update suppression doesn't kick in. Here's the same world, but this time I've changed the argument to 10 megabytes, so it's much bigger. And this is what happens if the auto suppression doesn't kick in. You see all the rails turn off, and that means that your JVM argument or the stack size that you've given is too large, and you need to build this device and make it bigger. The only thing you need to do is to basically take this slice, this area over here, and just copy it and make it a little bit bigger, or if it's not enough, then you just need to add more and more and more. And what you will actually experience if the first time you use this device is that half of the area might turn off, so you will update suppress. Then next time you turn it back on again, a little bit more will actually, a couple of more rails will turn off, and so on, until all of a sudden all of them turn off. And this means that basically your update suppressor isn't big enough. You need to basically increase the size of it. So the whole process of just testing until you know which size you need is something that you need to decide, like you need to figure out on your own. I don't know what JVM arguments that you're running on, or if you're running on Linux or Windows. So just check out the JVM arguments, and you can find it here, and then change it as you need to go. Or if you can't change it, increase the size of your auto suppressor until it works. Basically, that's an experimental thing that you can just figure out on your own. And I don't think it's that complicated to take a look at this device over here and just cloning it over one more block and just see when it starts update suppressing and when it's too small. Just be cautious that you don't build this device so big that it goes outside of your render distance. That can happen, that it causes crash loops if you're actually auto suppressing with the device being outside of your render distance. Sometimes these devices can be so large that they're going outside of render distance. If that happens, then you need to make sure that you have a person or player, or I don't know, in some ways this device is completely loaded by some ways. I'm going to leave this world as a world download for anyone that wants to just check this out. I'm going to clear up this area a little bit and just make a couple of examples of what update suppression you can do. And you just keep in mind, if you have any problems with update suppression, there is always Discords. I will leave a couple of Discords in the description. You can always ask people there. There's a lot of helpful people that can actually help you with any problems that you might have with this contraption. And it's very finicky. I would suggest to use carpet so that if the first time you're trying to update suppress, you know what you're doing. And if you don't know, it's best to use that carpet rule so that you don't cause constant crashes and corruptions that I just bumped into. Anyway, guys, bye-bye.